Hey guys, how's everyone doing? Hope you're having a wonderful day. And today's a continuation of our daily math lessons. So for today, we're going to be talking about square root functions. So let's get into it. So for square root functions, okay, just a general definition of it. If a function contains a square root of a variable, it's called a square root function or a radical function. Now, typically, that'll look something like this. F of x is equal to the square root of x. And that's the typical square root function. Now, before we can define all these characteristics of it, so domain, range, x-intercept, y-intercept, symmetry, not defined, in behavior, and extremis. So before we can define any of those points, we first need to be able to graph this function. So in order to graph it, we're going to kind of look at this right here. Okay. So as you can tell, we have our graph and we have our table on the side of it. So we need to first define the table so we can get our coordinates. So we need to go through that. So for the first one, the square root of 0. Okay, plug that into your calculator. We get a corresponding y value of 0. Square root of 1. Plug that in your calculator once again. You get 1. Square root of 2. Now these are where we start getting into I guess kind of irrational numbers where our decimal just keeps on going and going and going. So we're just going to kind of approximate it. So when you put this in your calculator, you get 141. For 3, we take the square root of 3, which is 1.73. Square root of 4 is a whole number. It's actually 2. Square root of 5, we get 2.23. Square root of 6, we get 2.45. Square root of 7, 2.65. Square root of 8, 2.83. And then lastly, square root of 9, that's a whole number finally, we get 3. So looking at these terms, there's actually only 4 numbers that you really want to use. These numbers where we have these decimal places like this, they don't help us out as much because they're really hard for us to graph because they keep going. It's an approximation when you graph it. So it's best not to try to think of those numbers. Anytime you want to do a square root graph, you got to think of numbers that occur at these locations. 0, 1, 4, 9. Okay, so with that being said, let's go ahead and graph it. For 0, 0, 0. That's our first coordinate point. We have 1. So for 1, we have 1, 1. Then our next one is at 4. So at 1, 2, 3, 4, 1, 2. We should be somewhere right here. And our last one is 9, and its y value is 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. So it should look something like this when we graph it. Okay. And this is f of x is equal to the square root of x. So this is how our graph will look like. Okay. So now when we're thinking about all our characteristics of it. So the first one we want to look at is domain. So what is happening? So as you can tell, we don't go anywhere negative in this problem. We start at 0 and we go to infinity as we go to the right, and it hits 0. So we're going to say, I'm going to have 2 answers for this one. Okay, the first one is we're just in our kind of our x and y, or our kind of our coordinates. So the first one we're going to do is 0 to infinity. Now remember, we can never include 0 because it's an abstract, or sorry, include infinity because it's an abstract number, but you can include 0 because we actually hit that point. Okay. Now, if you want a little easier method to write that, we just want to know the x values, right? So we can say or x is greater than or equal to 0, because as you can tell, x can be 0 or anything greater. So that one works. So for range, we can do the exact same concept as well. Now we're looking for up and down. Yeah, it goes to 0 and then goes up to infinity. So it's actually a repeat of the domain. So 0 to infinity, or y is greater than or equal to 0, because y can be 0 or above it. The next one we talk about is intercepts. Okay, x and y intercepts. Now, for us, it's pretty simple. We have an x-intercept at x is equal to 0 and a a y-intercept of y is equal to 0 at their corresponding location. So you have an x-intercept when y is 0, you have a y-intercept when x is 0. So same forth, it's kind of vice versa for this one. Symmetry. Is there any symmetry for this function? There's nothing we can do if we kind of break it apart right there, if we kind of want to flip it, if we want to kind of do a hot dog or hamburger, anything we try to do to make this reflect itself, it doesn't work. So this one doesn't actually have symmetry, so we're going to say not applicable. Okay. The next one we look at is not defined. Where is this one not defined? Well, as you can tell the way we drew it, everything is included in this one is 0 to infinity. So that means everything to the left of that is not defined. It can't do that. One of the reasons we don't graph that is because, remember, you can't take the square root of a negative number. You can't take the square root of -4, -1, and so forth, because they don't work. Okay? So we're actually going to say this one is negative infinity to 0. This time it doesn't include it, because we actually know that you can take the square root of 0. Okay, so this is saying everything can approach it, but it can't actually touch it. Okay, so you can say that, or once again, x is just less than 0. For end behavior, we want to know what's happening as this function goes to the right and to the left. So as we go to the right, what is happening? Well, as we go to the left, what's happening? So the first thing we're going to do is we're going to say as we go to the left. Well, as x approaches the left, it actually approaches the number this time. It approaches 0. Well, as x approaches 0, what does y approach? Well, it approaches the same as that thing. It approaches 0 as well. So then we talk about, so that's the left done. So now we're going to talk about as x approaches and goes to the right. So as x goes to the right, it goes on forever. So it goes on to infinity. And as x goes to the right, y goes up. So y goes to infinity as well. Okay. And the last one we're going to talk about are the extrema. So the extrema just means, is it a max or is it a min? For us on this function, as you can tell, it goes up to infinity and to the right of infinity, but it never crests. It only does that at this point right here, and there's nothing ever going to be lower than it. So we can actually say this: there is a minimum at 0, 0. Okay. So that's all we have for today's lesson. You won't have a quiz or anything associated with it, just because we're going over the properties of a square root function. Okay. I hope you're all having making the best out of this situation. I know a lot of you have jobs and are working your butts off trying to make money and do stuff for your families or whatever it is. And guys, my heart goes out to you. This is a weird situation to be in, especially for a high school student. But just do all you can at this point in time. Just stay safe and stay healthy, guys. I look forward to hopefully restarting school and seeing y'all again. I miss y'all a whole bunch, and that's all I wanted to say. Have a good day, guys.